Audio check. Audio check. Can you hear my voice? Cool. Computer screen check. Can you see my computer screen? What's going on, potty people in the 7th grade class? Let's start up our Science 7. So here's what we're going to talk about today. I want to spend a few minutes at some point in time talking about what your experiment is going to be. And then what I'd like to do is spend the rest of the time covering Lesson 2 from Chapter 8, talking about plant responses. I might do those out of order. Why don't we do some lecturing first? And then after that, I'll ask you guys, what are your proposed science projects going to be about? Josh Knight, I know that you just showed up just recently, so I'm just giving you a heads up. We're going to be doing a science fair project. It is going to be an individualized project, and it has to have something to do with plants, but there's a lot of things you can do, so it's really interesting. Cool? So I want you to think about what you guys are going to be doing, and I'd like for you guys to be able to give me a response as far as what you are planning on doing. Yes, it has to do with plants. Your science project can almost pretty much be anything as long as it involves some kind of plant in some way, shape, or form. Okay? The only other limitations that I'm putting on this project is that you should collect data over the course of about 2 weeks. Sound good? All right, let's do this thing then. You ever wake up in the morning because your mom turns on the lights inside of your room, and all of a sudden, like, the lights come on and you like react and you wake up? And what happens is, you ever what happens is you close your eyes even more, like you're like, Mom, yeah, where she turns on the lights or opens the curtains, all that kind of stuff. What happens is your eyes are responding to a stimuli, which is basically light in this particular case. A stimuli is any change to an environment that causes a response. For example, when you turn on the light, that's changing the environment somehow, and it's causing you to respond by yelling obscene things at your mom and saying, Mom, get off my case, I want 5 more minutes, Mom, and all that kind of stuff. Plants also respond to stimuli, although it doesn't do it like we do. It doesn't cover its eyes, it doesn't do it very quickly. It might take as little as a minute, but as long as a couple of hours. And certain stimuli have different response times to them. In fact, they might occur so slowly that we don't even think that the plants respond at all. But in fact, the plants do. For example, see these seedlings that grow? What happens is they grow up, and then the light is coming from the side. And how are these plants responding to that light that is coming from the side? Audience participation is encouraged in this class. Please yell out your answer. Are you able? You guys are able to see my computer screen, right? All right. Okay. So how are these plants responding to said light that is coming in from the side? Yeah, there we go. All right, fine. They're growing sideways. They're reaching towards the light. They're going up, and they'll be like, hey, folks, the light's on this side. Let's all go that way. Now, this didn't happen immediately. The light didn't come in the window, and the plants go boom, all looking at the light that way. This happened over the course of several hours. So, there are different words for the different types of environmental stimuli. For example, If you're talking about an environmental stimuli, that is called a tropism. Now, tropism is a response that results of growth towards or away from a stimuli. If it's a response towards a stimuli, then it's called a positive tropism. Whereas if it's a if it's a response away from a stimuli, it's a negative tropism. For example, lights will grow towards or not lights, but plants will grow towards the light. That is a positive or negative tropism. Positive or negative? All you guys got to do is type plus or minus. Come on, you guys. Okay, Jonathan, I'll check those out. But there we go, a positive. All right. Now, I got a question for you. Plants growth and gravity, is that positive or negative tropism? Plant growth and gravity, is that positive or negative tropism? Do plants grow towards gravity or away from gravity? Jonathan, I promise I'll fix that today. All right, there we go. Negative tropism. They grow away. Very good. Awesome. All right, here we go. So, plants respond differently. They have different tropisms. They have, one is light. So we can basically talk about how light affects, the direction of light affects the direction that the plant grows. Now this is, you folks can experiment around, and the reason why I'm going to lecture first before I go over what ideas you guys have for your thing is because as we lecture through this, maybe you guys can come up with different ideas for your projects. So we can see how light affects the growth of plants and the direction of the growth. A lot of times we see a positive tropism going between light and plants. Another thing is touch. This is called thigmotropism. The higmatropism. Thingimotropism. I'm terrible at these scientific names. Thigmotropism. All right. Basically, plants will respond to touching things. And there's different plants respond differently to touching things. For example, vines like to grow on other things. So vines will send out its little tentacles, and as soon as it touches a wall or a pole or the roots of something else, it will, yeah, I think we're recording. Yeah. As soon as the plants touch something like a wall or a pole or that kind of stuff, it clings onto them and it wraps around these objects. That is a positive tropism or thigmotropism. Does that kind of make sense? And then, for example, here's another one. Roots, okay? The roots of a plant like to grow down, right? But they also like to grow out. But what happens if they touch something else? Like they touch a rock or they touch the roots of another plant or something like that. What happens? What does the plant respond as? What happens is, as soon as they touch something like the roots of another plant or the wall or something like that, or a big rock, they grow in the opposite direction. There's negative thigmotropism there. And the reason being is because they don't want to try to compete with that other object. So they want to grow. No, they don't wrap around each other. In fact, they do the opposite. They try to get away from each other as best as they can. The reason for that is because it will allow them, if they don't grow towards the big rock or the wall or the other plant, it allows them to grow quicker because there's the easiest path through the soil. But it also allows them to not have to compete for the nutrients in the soil that they might need. You guys get it? And the last, or well, not the last, but another tropism is gravitropism, and it's the response to gravity. So what happens is, if you put a seed in the ground, for most seeds, there's a few that don't do this, but for most seeds, it doesn't matter whether you plant it upside down or right side up or sideways. There might not even be a upside down or right side up because it doesn't matter. The roots will grow towards gravity, and the stem will grow away from gravity. And this happens, you can actually grow this in dark chambers, like underground. This still happens because the plants aren't responding to light, they're responding to gravity. Which actually, to me, I think this would be, and I know I kind of highlighted this before, but I think this would be a fascinating experiment if someone wanted to do this, where they put a plant inside of like a PVC pipe or something like that, and they closed off both ends, but they still were able to feed it somehow. And they had the plant grow, like they had the seed in the middle of dirt, and then they turned the thing constantly. They constantly had the thing spinning. So in the seed's eyes, gravity's direction is constantly changing. In that case, I don't know which way the plant will grow its roots, or if it will even grow at all. I'm curious to know what happens. Anyway, you guys can do whatever it is you guys want, but I'm just saying, that might be an interesting one. I'm fascinated by that. Of course, leave it up to the physicists to want to talk about gravity and that kind of stuff. All right. You know what would be another interesting one? You know how, like, if you sit in a centrifuge, the other day I brought my kids down to the fair, or, like to the 50th State Fair, but it was like in Hawaii Kai or something like that. It was like Hawaii Kai Fair. And my kids' favorite ride is this planet thing where they go inside and it spins them around and it sticks them to the wall. That's their favorite one, right? And what happens is, you've got kind of a centripetal force thing going on, okay? Because the spinning motion kind of, your inertia pulls you out, right? So basically what happens is you're changing the direction of gravity from pulling straight down to pulling both down and out. I'm wondering if you can fool a plant, like if you put it inside, if you have it grow inside of a centrifuge that spins around, okay? I wonder if you can fool a plant into growing its roots in that new direction of motion. Anyway, I just think that would be fascinating for me. All right. Anyway, you might think that plants respond to light, that all plants respond to light, but some plants flowering is actually a response to darkness. Photoperiodism is a term that we use for a plant and how it responds to the number of darkness in its environment. Certain plants basically what I think they're saying is plants need a certain amount of sleep. It needs to be dark for a certain amount of time for it to flower. I don't know why, but that's the case. You have three different types of plants. One is called long day plants, short day plants, and day neutral plants. The reason why they're talking about the specific, like, instead of saying long night plants and short night plants and day or night neutral plants, is because in the past, scientists used to think that it was a response to light, but now we know that it's actually a response to darkness, which, to me, well, what's the difference? Anyway, long day plants basically require little bit sleep, lots of hours in the light. So they bloom during the summer. For example, carnations are long day plants. And they bloom during the summer because in the summer, at least on the mainland, the day is longer than the night. All right, long or short day plants, I guess you can also think of it as long night plants. Short day plants require 12 or more hours of darkness for flowering to begin. For example, a poinsettia, which is these red flowers that you see sometimes mostly during Christmas time, right? Those require more than 12 hours of darkness. That's why they bloom during the winter when there is more 12, around 12 hours of darkness. Make sense to you? Now they have day neutral plants which don't care whether or not how much darkness there is. They just care about how mature the plant is and the environmental conditions and all of that kind of stuff. And that's they will grow they will flower regardless of how many hours of darkness there is for that particular day. Is that interesting to you? You know what I think would be a fun experiment is if you could trick one of these long day plants into blooming at the wrong time. Like say that you have two plants, right? And they're both long day plants. And so you leave them out, right? And the carnations, maybe since we're getting so close to the summer, the carnations will tend to bloom, when it's longer days. But then you have another plant and you build a box and you put that plant inside of a box. And then what you do is you give the carnation shorter amounts of light than the other plant. I'm wondering if it's not going to bloom, whereas its friend who's outside the box will bloom because it's getting the right number of hours. I'm wondering how you can test this. You know what I mean? Like if you can trick or do that for the poinsettias. For the poinsettias, you have one plant that's outside and one plant that's inside the box. And then, the one that's outside will get too many hours of light. And then when the inside, you can cover up the box, only expose it to the sun for a certain amount of time and then cover up the box and trick it into thinking that it's dark for a longer period of time and then it will bloom. Do you guys understand my experiment that I'm just making this up now? I haven't thought about these beforehand. Anyway, if one of you guys want to take that on, I don't know. It's up to you, really. All right. Chemical stimuli. So we talked about touch stimuli. We talked about gravity stimuli. We talked about light stimuli. We even talked about phototropism or photoperiodism and that kind of stuff. Now we're going to talk about chemicals stimuli. So, plant hormones are a substance that acts as a messenger within plants. The reason why they call it a messenger in plants is because usually these chemicals and hormones are generated someplace else, and then they're put into places. Yes, this science fair project that we're doing has to do with plants. So you can choose whatever you want, except it has to do with plants. Okay? It has to have a plant involved. I know. You guys keep asking me if you guys can do. I got a question. What experiments do you really want to do that don't involve plants? Because it sounds like you guys, or do you guys, you want something with explosions? Okay. All right. Here. What about this? What about you take two plants, okay? And you know how on New Year's Eve, at least when I was a kid, the smoke used to get so bad I wouldn't be able to go outside. You know what I mean? Because like when we had like the smoke bombs or something like that, it would just cause so much smoke, so much sulfuric, you know, smoke and smell in the air from the fireworks that it would trigger my asthma and I wouldn't be able to go outside. I'd have to stay inside of an air-conditioned room for New Year's, every New Year's, because I mean that's how crazy fireworks were when I was a kid. Now that they have all these laws and bans on them, I don't think you guys experienced what I experienced when I was a kid. But I'm just saying, I literally just gave you "when I was a boy" speech, which makes me yay years old. All right. Anyway, I'm wondering if like that affects the plants. You know what I mean? I'm wondering if you get like two jars and you have one jar that, you know, it's just regular, you water it every day, all that kind of stuff. And you have another jar where you put a firecracker inside of that thing. Maybe not a firecracker, but some kind of smoke bomb or something that releases smoke every day. How does that affect the plant's growth? You know? Like if you put a candle inside, it's going to burn up all the oxygen, right? And that's actually a good thing for the plant. You know what I mean? So I'm wondering if you light a candle inside of a jar that has a plant in it every day, so one of them is having less oxygen than the other, will it be good for the plant? Will it be bad for the plant? Do you guys see how you can marry the things that you're really interested in with this experiment? So I'm not really limiting you to what you want to do. You guys can you can do that, and that would be a cool, interesting experiment. I'm curious to know what the results of that would be. Oh, that's pretty funny. All right, anyway. Auxins. So, auxin is a plant hormone. Now, auxin is basically here's this is really interesting. Auxins, what they'll do is they'll build up on the side of the plant that doesn't have as much light. So imagine like, I don't know, imagine um well, imagine carrying a door on top of your head. So you have a door that's carrying on top of your head. In fact, you have two people carrying the door on top of the head, on top, over their heads. Okay? One person is really tall and the other person is really short. What happens to the door that they're holding above their heads? Assume that they're both strong enough to hold it. It slants. Very good. Exactly. There we go. So auxin is a chemical where it grows on the opposite side where the light is. So it grows on the dark side of the plant. And auxins grow faster and bigger than the regular, chemicals in the plant that make it grow. And so what happens is, what's going to happen to that plant? Well, it's going to slant. And how is it going to slant? It's going to slant towards the light because the bigger, taller, in our case, taller person is on the opposite side, is on the side that's away from the light. So then the door slants or the plant slants will turn towards the person. Does that make sense? So that's a type of chemical response. All right. What about this? Could it eventually fall over? I don't know. I'm wondering if, what if you did this? What if you have a plant and you had, you know how you have a plant like this? Let's say you have your plant and it's on a lamp, and it has a lamp like this. You know what I mean? I'm wondering if you could every day move the light, have it grow, have the light be right over it and have it grow for a day. And then the next day you move the light 15 degrees or something like that. And have the plant grow. And then the next day you move the light 15 more degrees and 15 more degrees. And you do that over the course of a month. and then you have it go all the way around the plant somehow. I don't know. I'm just making this stuff up. I'm wondering if it will fall over, like you said, Isabella. I don't know. I don't know. And you can experiment with these things. That's my favorite thing about this lecture today. Is basically you ask questions I don't know the answers to. That would be a great experiment to do for your big science fair project. All right, here's another one. Ethylene. Ethylene is a gas, and it helps stimulate maturity inside of like plants and fruits and seeds and flowers and leaves and all of that kind of stuff. One of the things, I don't know if you've heard that saying, one rotten apple spoils the whole barrel. And that's back when they used to, have apples in a big barrel. And if one apple was rotten, what would happen is it would produce a gas called ethylene. And then the other apples around that apple would respond by ripening faster and rotting faster than the others, or than normal. And then they would release more ethylene, and then the apples next to it would respond by, producing more or ripening faster than it should be. So you can have a whole barrel of rotten apples if you had one rotten apple in the first place. Crazy, huh? Or like, here's another one. Bananas. Bananas can actually be picked, and most fruits that you see in the store, they can be picked when they're super green, when they're not ready to eat at all. And stores, and they can, and you can ship them all over. You know what I mean? You can move them all over the place because they won't really ripen if you just leave them out. But stores can ripen them really quickly by treating them with ethylene. Yeah, yeah, Isabella. That would be That's completely accurate. If you put a ripe fruit in the bag and an unripe fruit in the bag, it will cause the whole thing to ripen real quickly because of the amount of ethylene that's being produced. But what I'm saying here is you can actually stores do this where they treat their super green bananas with ethylene, and then that causes the whole thing to ripen at the time they need it to ripen. I think that's fascinating. To me, it's crazy. All right, here's another one. Gibberellas, gibberellins. There we go. All right, gibberellins. So, gibberellins is a hormone that causes cell elongation inside of stems and leaves. Look at this. The grapes on the left side have been treated with gibberellins, and the grapes on the right side were not treated. Now, which one looks better? The one on the left or the one on the right? The one on the left, right? They're like twice as big. I mean, each grape is like twice as big, plus the stem is like twice as long. Sweet. If I could grow my grapes like the one on the left, I'd totally be down. Now, to be honest with you, I'm not a big, I'm not necessarily that big into like the whole organic movement, although I'm sure that some of you are, like what Jonathan's bringing up right now, where like, hey, maybe those ones on the left might be being treated with like some kind of crazy radiation or hormones that aren't good for us to eat. All that kind of stuff. Maybe that would be a good experiment for you to do. To see how much hormones you can give in order for it to grow, and if there's too much hormones you can give in order for it to grow. You know what I mean? So you plant like something without any of these hormones, and then you could basically go ask any company that is involved with these growth hormones and see. You know what I mean? You can ask them, hey, I'm really interested in doing an experiment on the hormones. Do you think I can get some of this material or fertilizer or whatever from you and see how that works. All right. So, with all of that said, does anyone have any questions on my lecture on plant responses? What happens if you water a plant with alcohol? I don't know. I don't know. Maybe that might be a good experiment. You can get like rubbing alcohol and dilute it to different concentrations and water different plants with those different things and see how your um, plant responds. Or milk. You can even do milk. You can have like maybe 10 different plants and you have one plant on the end where you water with pure milk, and the other plant on one side that you water with pure water, and then you have like all of these concentrations of milk in the middle where you water the plant with milk. I'm wondering if that makes a difference. You know what I mean? Yeah. So I have a question at this point. I want you guys all to respond. What types of experiments are you interested in doing? What is some of your proposals? And if you propose it to me now, it doesn't mean that you have to. That's exactly what you have to do. But I'm just trying to get an idea of where you're going with this. So Isabella, um, you want to do watering with different materials and see if that works. Cool. Maybe Isabella, it would be good if you did one that had like different amounts of household chemicals in it to see how our use of different household chemicals, and then we're throwing that inside the trash, the different dilutions of household chemicals, cleaning materials, affect how well or how not well plants grow. Sierra, I actually have an aquaponics system. Um, are you on Oahu? You are, right? Yeah. If you want, you can come down and pick it up, and then you can. I actually have it set up. It's got a little uh, 5 gallon tank in it, and everything. The pump, the whole thing. I already built it. I don't know if you already have one, but that'd be an interesting one. I also know a few people who run aquaponics farms, so they might be able to help you out with your experiment. Let's see. Uh, yeah, Jonathan, I like that idea of the different fertilizers in plants. Yeah, Faustine, that would be a good one. How well or not well do plants grow with different like sugars, amounts of sugar inside of the thing, right? Or if the bubbles make a difference. Casey, are you having trouble thinking of one? All right, cool, Sierra. All right, who else is here that I can pick on? Chelsea, do you have any ideas? Quinn, Bo, what's your thoughts? Oh, okay. So Quinn, you went on that one website that I set up for you, right? Okay. So there was a website that I sent out in an email. It's called Science Buddies. Okay. Yeah, it's called Science Buddies, and it's like the section on plants. And I basically said, um, go on that. That will give you great ideas. And Quinn liked the first one he saw, and uh, and I think that's a good one. Let's do it. Can you use a plant to determine the water quality of that plant? Because we already spent a lot of time maybe thinking that can we use plants to improve the water quality of plants? Well, now can we use a plant to determine how good the quality of water is? That'd be a good one. I like it. Josh, you have any ideas, or can you even hear me? Chelsea, you hate plants, but you're gonna go check out that thing. All right, go do that. I want to microwave water and see if the plant will grow with it. Hmm. Okay. Okay. So I have a question, Bo. Are you thinking about experimenting on how the temperature of the water affects the plants? Or are you thinking about experimenting on how maybe microwave radiation kills the plants? And Chelsea, that actually might be a really good experiment. Is how do you get a plant or Chelsea, that might be a good experiment is how do you get a plant to not die? All right. For people that are going to use different types of watering, what if you did it with fruit plants and seeing if the fruit tastes different? That would be pretty interesting. Absolutely. Go use a plant that is already has some kind of small fruit and then set up a blind taste test. So you need to find a plant. You don't need to grow any of your plants from seed, by the way. No one needs to do that. You don't have to grow your plants from from just the seeds. You can go out and buy a plant that already has some fruits on it. Okay? And I would choose a small fruit, a small plant, small fruit. And what you could do is, I think, Sierra, your idea, I like that idea. What if you use like flavored water? Or what if you use like dirty water, like dirty water versus like purified water? You know what I mean? All right. Bo, for your experiment, I would recommend that you. Hmm, I would recommend that you don't try to test both at the same time. Your experiment on microwaving water, I like that idea. But what I would do is you can set up two experiments. You can set up one experiment to say how does temperature affect the water, and then also how does radiation affect the water. And so if you want to test just radiation without testing temperature, then what you're going to need to do, Bo, is you're going to need to maybe um, microwave some water, like a lot, like maybe 3 minutes for water or something like that. So where it gets really not hot, but just a lot of water in it. Okay, and then you're going to need to put ice cubes inside of that water to so that way you can get that water to the same temperature that you would that you can get the water to the same temperature of the non-microwave water that you're going to be feeding. And then I would use two different plants, or not two different. I would have two plants, and for one of those plants, I would put regular water, not microwave, And then for the other plant, I would put microwave water, but at the same temperature as the other water. You know what I mean? So you need to make sure that you have the same temperature, because if not, if you try to test too many things, then what you're doing is you're not controlling your variables. And what happens is you won't be able to say that the one that doesn't have any microwave associated with it grows bigger. You won't be able to say, well, it grows. My plant that uh, had microwave water didn't grow as well because of the radiation. You won't be able to say that because you don't know whether or not if it's the radiation or if it's just the fact that you've been feeding your plant hot water. You know what I mean? And you can even set up a separate experiment to say, okay, now I'm going to test, I'm going to have one water that is, cold water and other water that is hot water. And I would recommend maybe putting that water on the stove and using that kind of water. Yeah, yeah, Ciara, that would be a great experiment. In fact, I have um, those uh, lights. I have those light covers that they use in theaters to, change the color of lights. If you want to come down and pick those up, just remind me because I have them at home and I have to bring them to work. So yeah, you can set up two different experiments. We're actually done, but around now we're done already. The reason why I'm just hanging out with you guys now is just because I'm 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 trying to help you guys out with your ideas for your experiments and see where what it is you guys want to do. But no, we're done. You guys can go if you want. All right. Anyone else have any ideas that they want? Because I think that I asked you guys to submit a proposal by the end of today. Let me just check real quick. A before science fair. Okay, here we go. Your proposal, which is worth 15 points or 10 points, is due today, and it is asking you to, let's see, how many people turned this in? Did anyone turn it in? Okay, only a few of you turned it in. Okay, I need to help this person out because I would say this isn't a, there's data behind this one. All right, so make sure you guys turn this in because we're going to be addressing this thing. All right, I have a question, but okay, how come the previous needs answers? Yeah, yeah. If it says needs answers, it means it's incomplete, and I shouldn't have assigned it to you. Oh yeah, I forgot to ask, Jonathan. You said that there was some problems that I had that I didn't address. You want to tell me about them? Or which ones did I say? Which of my assignments would you say that really kind of didn't work? All right, the ones that are due on the 28th and the 30th. Let me see. Let me look at those real quick. Let's see. All right, which problem was it? Oh, let's see. You're right. You're right. And then over here, I didn't even put the answer, huh? Yeah, you're right. It's cellular respiration. And I put the word blank. You're right. All right, and you said the next one was junk? Okay, let's fix that. I apologize. Oh, you notice how it says it needs answers? I guess I didn't see that, so I forgot that it needs answers. All right, let's see. Which is not likely to cause a plant's response? Changing the daylight, moving the plants away from each other. Mhm. I would say your best answer is B in this one. And notice what I'm going to do is I'm going to say, well, if they got a wrong answer, or if they got the previous answer, or the correct answer, I'm going to give them credit. And then for this one, what is percent increase? You're right, 75%. Okay, sorry about that. It's fixed now. All right, cool. So by then today, I need you guys' proposals on your plant stuff, and I'm going to respond to them. All right, talk to you later. Thanks for coming. Goodbye.